Hello everyone and welcome to Rudy's Retro Intel. On today's show we'll be looking at this RC2014 vintage computer. Let's talk more about it and peek inside, poke around. Stay tuned. So this is the RC2014 computer. It comes in a backplane with cards you plug into it, and that's basically what you're getting. The neat thing is that you can get all these individual cards. You can add, modify, build your own cards, whatever you like and want to do. So let me just pull out the cards, and we'll take a closer look at what's going on here. So first thing is we have the backplane here. It's quite a bit of soldering. I've added some rubber feet for support, so when you're pushing down you're not flexing the board. And what it comes with, it says RC2014 Backplane Pro. This is the Pro version. The difference between the Pro and the non-Pro, the Pro has multiple slots. How many slots do we have here? We have 12 slots, and the regular one, or the standard one, I believe only has 4 or 8, I can't remember. But I want to buy this one because it has room to add more functionality. Like I said, it's pretty simple. It's got an on-off switch. It's got a barrel jack for your plus 5 volts. I'm running mine off a USB cable with a phone charger adapter. You can plug in power directly into here. All you have to do is add the 7805 regulator, a couple of capacitors with a screw terminal here. There's also a reset button on here and a power LED. Now each one of these slots, you can put your cards in basically whatever slot you want, and it's nicely labeled. It has all the address lines, data lines, reset lines, all the lines labeled on here, so it's pretty cool. The back, again, like I said, is just a lot of soldering. It takes a while to do this. However, if you're an intermediate or higher, I guess, soldering expertise, you can sit here and just solder. And believe me, by the time you finish this, your soldering skills are going to be much improved. So the trick is just ensure that you're soldering properly, no bridges, no shorts. With the solder itself, you are putting in the right headers in here. There's a longer one and a shorter one. There's a great documentation on all the builds for this and all the additional cards. So now let's look at the cards. Well, one of the main cards you're going to want to get, or you should get, is the Z80 or Z80, depending how you want to pronounce it. It's the CPU card, and it's just a simple card. Has a couple of resistors and the CPU socket itself and the CPU. This one has dual headers. I'm not sure it's showing up on the camera. There's 2 rows. There's one longer which fits in the longer slot here, and then a smaller one. So when you're soldering it comes with the appropriate headers, and you just solder them on. Ensure that they're on straight, so when you plug in the board, like so, that they're actually going into the second row, is actually going into the second row here. So that's the CPU card. The next card, let's take a look at this card. The nice thing is all the cards are labeled on the back. This is the ROM card. It's a pageable ROM card. This has a few more chips. It's got the ROM chip. It's got some support logic, and it's got jumpers for different address settings. So you have the 1K, 2K, 4K, all the way up to 32K. And again, it's as simple as just soldering a bunch of sockets, a few resistors, and the header. This one also has a second row, which is much smaller. The next card is this one here. This one is the 64K RAM card. This one again has just 2 EEPROMs, some support logic, and jumpers, and again 2 rows, or partial 2 rows of headers. That's only the middle section here that's actually being used. and it's labeled on here for the different starting addresses. You have what is this, 0, 1000, 2000, 4000, and a little diagram as to how to place the jumpers. Again, this is all in documentation. If you go to the RC2014 site, just Google it, you'll find the builds, how to build the cards, all the components, and how to set all the jumpers based on your needs. The next card here is the clock card. This is the dual clock and reset card. This has a dual clock, which is needed. You need a clock to run the CPU, or else this is not going to go very far. Again, this one is a bit more work. It has the support ICs, resistors, couple of capacitors, the crystal for the clock. There's 2 clocks on here. You can set them however you like, and you can have an external clock if you like to set up, and the reset button for the clock. The next card which you want to get is this one here. This is the dual serial card. This allows you to plug in your terminal or external monitor to an external monitor, like you can use a laptop, a desktop, a smart dumb terminal, whatever kind of terminals you want. This pen is bent, it's bothering me. Let's fix that up. Oh, what happened here? That's strange. Must have bent it. There we go. So you can plug in your adapter. Now, I've purchased this separately. This is an adapter for a USB to serial. It's quite nice. It's not that expensive. You can find them on Amazon. Can't remember exactly how much I paid for it, but it's you can find them pretty much anywhere. I would recommend making sure you get the ones that have labels on the card itself, so you know what pins go where. And that allows you to plug in, like I said, your keyboard and your monitor. The final card I purchased was the flash card. This is the compact flash storage card. This comes, if you buy it, you can ask if have this portion already pre-soldered to the board. It is a little difficult to solder, so I just ordered it with it, and I ordered the RC2014 flash adapter or flash card, and it already has software on there. Again, this is just this one is only a single row, so make sure you plug things in the proper slots. Nice thing about this card too, it has an LED, so it's showing you it's an indicator for reading and writing from the card. So let's put this back together and then plug it into my desktop computer and see what we get. Okay, so let's start plugging our cards in here. So the first card I want to plug in is the CPU card. This is the Z80 or Z80, depending where you live. And I've put it in slot 3. So I'm just checking my notes on the side here. Slot 3. So these are listed slots from 1 to 12 here. And you want to ensure that the edge of the card, let me see what's showing up here. The edge of the card is in the right direction. You don't want to be plugging it in backwards and so on. So you want to face that towards the front. So let's plug that in here, slot 3. Where is slot 3 here? Now it's a little finicky because it's got pins. It's not like, for example, an Apple II has the edge connector on it. This has pins, so you have to be careful when you're plugging this in. Now the card, as you see, has dual pins, and the dual pins are on this side of the board, so you can't plug the card in this way because then your dual pins will be sticking out. You have to plug it in a way so that all the pins are being inserted into the right location. The other thing to watch out for is that you don't want to plug the card in too far back or too far forward. The slots have extra pins on them. I'm not sure why it was designed. I guess for future cards that have that are longer, that require you can plug into this slot. So this one goes in this way, and let's put it in. So I found that I put this in slot 3, which is here. So this will go like this. Again, make sure you line up the pins correctly. So in this case, it's the card the edge, the slant of the card is facing to the back of the computer. If you want to call this computer, is actually the back plane. So as we can see, we have two. Let's see if it's showing up here. We have two extra pins back here, so you don't want to make sure it's not offset and plugged all the way in. All right, so the next thing I want to plug in is the ROM, which is this card here. This is the RAM. Now, this is the ROM card. This will go in slot 4, and it's labeled back here. This is slot 4. Again, we're going to make sure we line up the pins correctly to the front and plug that in. Slot 5. Oh, let me change this around here. I made a little mistake. Now the boards are a little stiff to pull in and out, so just be aware. I grab it from the side and hold the board as I'm pulling them up. The CPU card I put in slot 3, which is, sorry, the CPU slot 5. So slot 5 is right here. So let's plug that in there. There we go. I was a little off camera, sorry about that. Slot 3 was the compact flash. It's this card here, and that goes to slot 3, which is right there. So slot 3. Now, you can plug these into different slots. I just found that this configuration worked for me. I'm not sure why putting the cards in other slots doesn't work for my situation. Others said it doesn't matter, and others say, oh, it does matter, you have to put them in a specific way. I find putting them in this way works best. I'll leave a description in the video as to where I put the cards in mine. So we have that. Next thing though is the dual clock, which is this card here. This is the dual clock. And the dual clock goes in slot 6. Let's plug that into slot 6. All right, and 64K is this one here. This is the 64K card. 64K, and that goes into slot 7, which is the next one. And then slot 8 is the serial card. So let's plug that in. Let me see if I can get a better angle on this for you so you can see what I'm doing here. So that just goes into the first pin. And that just slides right in. So now we have our configuration. Now here's a note I want to show you, a little something I want to show you. When you're putting the headers on the bottom of the cards, okay, make sure you have them lined up straight and not crooked. If not, you'll get this. Just looking at my side camera, make monitors, make sure you can see it. See how this card is like slightly bent this way. So the trick I found was to take your card, and what you do is solder one pin at a time. So just solder the one pin here, and then check to ensure that it's the right angle, the angle is correct. And if not, you can just put more solder on here and bend it. The other option what you can do is you can pull out, if you have, pull out a breadboard. So let's put the breadboard here and plug that into the breadboard, and then you can solder to, you can ensure that it's all lined up properly when you're soldering them up, and that way you don't get this where some cards are, you know, crooked and others are not. So let's finish putting this back together and fire up the terminal software and show you how to configure it and get it going. Now that we have a terminal program, I'm using Term. I like it. It's a good Windows product. I'm not sure if it's available on Linux or Mac, but it's an older program. Term, very good. Now before we start, we have to first go to, in Windows, Computer Management, and we want to go to Device Manager, and we want to look at the COM ports. In this case, I'm using a USB cable, so it's COM port 6. we want to right click on that, click on properties, and go to the port setting. And we want to ensure that this is set to 115200. That's the speed. And then we have bits 8 data bits, parity is none, stop bits 1, flow control none, and that's it. So that is good. We can close that now. And on the terminal program, we want to make sure we want to go to setup, and then we go to serial port. Again, we want to make sure this is the correct serial port. This is COM6, and it's 115200, which is the speed. 8 bits for data, non-parity, 1 stop bit. And another important thing here is you want to make sure that your transmit delay is 2 or more. Some cases you might need 3 or 10 or 2, but having a default is 0, there's issues. So by giving it a slight delay of 2 milliseconds per character, it's good. So we can click open here, and we turn on the RC2014. And now we see a hit space to activate console. If you don't get this, then you have to hit the reset button on the RC2014 on the backplane. There's a button there called reset. Hit that, and this will come up. So let's hit spacebar. And now we're greeted with a prompt: Z80 SBC boot ROM 1.1 by G serials. Type question mark for options. If we hit question mark, we can hit R for reset. We can do a BC or BW, which is a cold or warm start. We can boot if you want a specific location from disk, which is X. And what we're going to be doing is just press X, and CPM should be coming up. So let us hit X, and it says, do you want to boot CPM? Yes, because that was what was installed on the card. Hit yes, and here we are. We're on CPM. So dir shows you what I have in some files. At download.com, list, cat, and delete. List is a program that shows you what's on the drive. It's like a dir command or directory command. Cat is similar to that. It gives you a nice listing of what's going on. On the B drive, what do we have here? I just have a program called dpec, which is a decompression program, kind of like zip, WinZip or unzip. You can uncompress files. On the C drive, I have a bunch of programs on here too. There's load pip, pip is a copy command, and we have delete. Type is to type out a document. We have the cat command here too. As you can see, we have that there. I have Othello, and ed is an edit program. Now on the D drive is where I keep all my basic programs. So in this program that we'll be using is mbasic 85. So let's type mbasic 85. Now, as you can see, we're starting up in basic. So now we have a basic command. We can type some program in, and print hello world, and list that, and we can run it, and we get hello world. Cool. Now, if you want to see what files you have on your drive, and you can't do dir because that doesn't work in basic, you type the word files, and it gives me a list of the basic programs, not just basic, all the programs on the current drive. So let's load up a program. Let's load let's see, retro.bas. So you need to put quotes at the beginning and at the end, and you have to specify the extension, which in this case is BAS for basic. If I hit list, there's the file program. We can run it, and we're getting the Rudy Retro Intel. Yay. Okay, so I want to type new. I want to do files. I'm going to load, let's say I want to do CPU speed .bas, and here excuse me, here I've written a little basic program that loops, in this case line 30 loops 25 times, and for each loop number it figures out the value for sin, cos, tan, and the square root of that of the value for the current loop, and then just exits out of there. And the reason why I created this is I want to create a basic program that can run in different basic systems. So for example, basic 85, I've already run it on the Apple II basic, the Nabu computer basic. I'm going to run it on other computers running basics just to see which ones are running the math functions. These are all math functions faster, or the fastest. So let's run this, and you can start your stopwatch, close your stop your stopwatch at the end, and now you'll know how long it takes to run all this. So it does all the calculations. So for example, loop 24, it finds the sine of 24, cosine of 24, tan of 24, and the square root, and then this displays the information. And that's really it. If from here we can type in system, that will exit out of basic, or in this case basic 85, and we are back here. Now you can also go in the program here and we can say clear our screen. So because there's no clear screen command unless you find one and download it and install it, but there's nothing here. So what I want to do is go back to here. So on the A drive, there's a program called download.com. And download.com allows us to send files from our desktop, or in this case our console, to the storage device on the RC2014. And there's a program you can run. I've already loaded it up. And it is a binary to CPM package, again by the same author who created this basic. And it's very simple. All you do is you say you want to import a file. So let's say we want to import a program. I don't know. Let me find something here we can load up. And I have some of these files already. I should have thought of this sooner. Let's see. All files. No, this one's not complete. I don't know. Let's pick I don't know, Star Wars.bas. That's the basic program. So let's open that. And now it says import complete. File added to the package file.txt. So that's good. Now from here, all we do is open the package, and it'll open it up in a notepad or some kind of whatever editor you're using. And it's converted into looks like hexadecimal here, and it uses the download program. So it's going to run it from A, and it's the download Star Wars.bas, and then here's all the info. So what we do, we select all of the data, the whole screen, and then we copy it. Here we can close this now and just come back to here on your console, and we right click, and TerraTerm is going to paste the content of the clipboard into TerraTerm. So we hit OK, and as you can see, it says download Star Wars.bas, and we have dots, and the dots are showing that it's the progress of the file being transferred. Now, even though this is quite high speed for serial, I'm going to fast forward this part of the video so that you're not wasting your time by watching dots appear. All right, now that the file has been loaded, you'll get the OK notification, and you're back to the prompt. So if we type dir, which you see Star Wars there, right? Now I can go to, let's see, what's on my D drive. Okay, I'm looking for a program called pip, which is on the C drive. So I want to move that file to my D drive where all my basic programs, so I can run C:pip, and then you want to put the destination first, equals a colon, and then so you're looking for so C: is where the pip file, so it's going to run from C. The destination is D, and the source is A, and it's Star Wars .bas. Now if we go to the D drive and do a directory, we can see the program is there. Okay, so now let's load basic 85. And what we can do, we can just type, we can load basic 85. Here we are. And then we can load, and then it's Star Wars. And now it's going to take some time because it's a good size file. Okay, we can list, and there is the whole listing. Control C stops the screen, and then we can run this. And here we are, Star Wars program up and running. And this gives us the Star Wars story. And it's kind of neat. But you can see how we can then transfer files from your computer, your laptop, tablet, whatever you're using as your main console, to the RC2014 and to run your program. So you can now load up whatever you like. There's a whole bunch of business software. There are some games with their text-based games like Zork. You can download that onto your computer and then copy it across through your serial cable. Now the next thing you'd want to do is now that this is all set up and running, your computer is actually working fine. If not, you can go to the site, and there's all kinds of excellent manuals. Now here, if you want, I went to the site and found that the RC2014 has different settings for, in this case, CPM. You have to ensure that you have your 64K module. It's set up this way for the banking starting address. Your ROMs would be this way, and your clock and so on. So it shows you how to set things up. Now let's do this. Let us do RC2014, and we'll do a search for that. And we can go here. It's the Homebrew Z80. And here we have a list of all the different types of packages you can get. You can get the classic, for example. This is the classic, which is shorter cards, less boards, less slots. There's the micro one, mini. There is CPM, a mini CPM upgrade if you want. There's also another Pro. 2014 mini. There are backplanes, like different types of backplanes you can get. I have the Pro, this one here, and it gives you instructions how to put it together and the bill of materials. Another interesting thing is the modules. So you have different types of modules. You have the 512K module. You have a bubble LED, and that's kind of neat. That's little bubbles for LEDs, kind of old school, very old school. We have the compact flash, which is I have both, this one and the original one. A digital I/O. This is neat. I have this board, and I am thinking about putting it together. And what it does is, from basic. So from here, for example, you can see you can output or input data to and from the LEDs or from the buttons here. So you press a button, it'll register in your basic program. Or if you want to say, okay, if I press this button, I want you to light up the LED, you can set that up. The neat thing with this is that it's kind of like a beginner's guide to working with external devices in basic. So you could hook this up to lights or other things and control your project with your RC2014. So you could do is replace the switches with a servo motor or another a relay or something else to then play around using your computer to do many other interesting things. So I have one debating if I should put it together and make a video on it. I think it looks fun. There's an IDE hard drive. There is also a Wi-Fi adapter, so you can set up Wi-Fi on your unit and transfer your files that way. There's a Pi 0 terminal, and this allows you to plug in your keyboard and your external composite monitor directly to the board, so you don't have to use a console like I am doing right now. You don't have to use a separate computer to access your computer, your RC2014. And there's a bunch of other ROMs, other interesting things. There's also a troubleshooting guide. There's a troubleshooting guide getting started. There's one if you have to look at things visibly. You can use another one. This is for troubleshooting with a multimeter. So if you don't have a scope, you can use the multimeter. Shows you how to do that. And then one with an oscilloscope, which is quite nice because it actually gives you the diagrams, the waveforms that you should be seeing on your unit. And so you can go to the site, rc2014.co.uk, to look at all the interesting things for the RC2014 kit and buy them. It also has, like I said, sorry, I don't know if I mentioned this, but the assembly guides. So if you're picking, I don't know, I've picked the terminal assembly or the Pi terminal. You click on that, it actually will explain and show you what parts go where and even provide a schematic. Well, that's it for our video today. Hopefully you enjoyed looking at the RC2014 computer. It's pretty neat. It's a great little kit. You can practice and improve your soldering skills, troubleshooting skills, learn CPM and basic programming. You can run other apps that are CPM based. If you're not aware, I've just created a Patreon page, and I want to thank my very first Patreon member. Scrolling at the top of the screen, it's Geek with Social Skills, and a big thank you to him. To my current subscribers and viewers like you, I really appreciate you watching and supporting the channel. If you'd like to know more about the RC2014, you can check out their webpage. You can just Google RC2014 computer. And if you'd like to see more videos on the RC2014, let me know in the comments below and we'll put another one together. Thanks for watching and have a great day.